As in the previous case, the financial model is available either by clicking here or by clicking here. The aim of this tool is to assist both parties, the owner as buyer and the technology provider as seller, to find a sweet point for a win-win deal. That means that the net present value of this project, or these streams, cash flow streams, for both owner and the technology provider, the seller, should be positive. So, given, let's say, the information, the financial information for the acquisition or the installation of this technology, we try to find the regions where a sweet deal is feasible. How is this possible? It is possible as following. We have a range of financial input. You can see here the cost of equipment, the advance payment, and all other data that we need for the typical NPV model. Then we have the key technical data, for example, the installed power, the specific fuel oil consumption, and of course input like the average cost of fuel, that is of course a parameter here, and the average cost or the estimation of the CO2 ton, of the CO2 price per ton, for example 120 or 190 as for example here. So given all this input, what we get the results, the NPV for the owner and the NPV for the technical provider. As you can see, this is a fair deal because the NPV for both owners and technical provider is positive. What would happen, for example, if the savings, the estimated savings or the expected savings are less than 14%, for example, 5%? As you can see here, this is not a sweet deal because it is a deal that strongly favors the technology provider. And this is a very simple example how the input that we provide is leading to a solution that is feasible for both sides. Needless to say that both sides have to agree. They have to discuss the input and then they have, let's say, to evaluate the results. The answer here of this model, the reply of the model, I think it's pretty straightforward. If let's say both values are positive, then this is a sweet deal. However, in reality, both sides will negotiate issues like the advance payment, the input, let's say, of the carbon price, of the fuel price, or the savings, etc. So, how can we find a sweet point given this input? What we saw here is, for example, that for a carbon price that is 140, an advance payment that is 5%, what you see that you get a green value, that is the 90%. What is the 90%? That more or less the owner and the technology providers enjoy the same NPV. This 90% means that the owners enjoy a 90% of the NPV of the technology providers. In this case, the 0%, as you can see, is that the owners have 0 as NPV, while the technology providers might get a positive value. So what would be this case? 80 for carbon price dollars per ton and 25% advance payment. The same can be considered also for the fuel price. So assume that we have a fuel price of $750 per ton for the fuel and 120 for the carbon price. The NPV of the owners is 32% of the NPV for the technology providers. And the same applies here for the savings, as you can see, from 2.5 to 20% vis-a-vis the fuel price. So the idea here is that given this input that might result also to negative or let's say to unfair deals, we have always, let's say, the tools to identify where we can find the green region that is closer to a fair deal, to a win-win situation for both sides. The model is, as I said, based on the NPV criterion that is widely used in all financial calculations, and it is a model that we think that's pretty straightforward for all users and technology providers.